course I didn't. So the variable of interest is what are the individual observations. So let's say I start a question and I say 15% of Columbus residents are having really bad allergy symptoms right now. Is everybody with me? What's the variable of interest in that case? Individual allergy reactions. Like essentially, yes or no. Are you having really bad allergy symptoms right now or not? Okay, so like the variable ends up being, did they say yes or no to having really bad allergy symptoms? Do you guys get what I'm saying here? Okay. All right. And once you know what are those individual observations, what do they look like? What does that raw data look like? You can decide, is it quantitative or categorical? Okay. Quantitative means numeric. Categorical is typically words. So if I take that idea of allergy symptoms and I say, one way I could measure that is I could go around and I could say, hey, Luke, are you having allergy symptoms right now?
Yes, I am. Yes.
Sylvie?
No.
Sophia?
No.
Et cetera, right? That's one way I could do it, and that would be a categorical variable. Another way I could do that, Sierra, how many times have you sneezed in the past hour?
0.
Is that also measuring allergy symptoms? A different way, yes? And in that case, that one would be quantitative. Are we good so far? And whether or not my variable is quantitative versus categorical tells me a lot about how I'm going to summarize and make conclusions from my sample of people. Everybody good? If it's categorical, we might use, like, I don't know, a one sample z-test or z-interval to estimate what % of people are saying this. If it's quantitative, we might use like a t-interval that says the on average with like, I don't know, with 95% confidence, we can say the average number of sneezes in the past hour is XYZ. Everybody good? All right. So, when we represent categorical variables, we typically represent them as either counts or proportions. Certainly proportions are better, okay? And we could also, like, if I wanted to somehow come up with a visual or graphical representation, it's almost always going to be a bar chart or a segmented bar chart. Now, when it comes to quantitative variables, which is the bulk of what we're going to talk about in Unit 1, those quantitative variables, we can represent them a lot of different ways. We can do a dot plot where we have our axis and we make dots, right? If you're ever asked, you need to label and put a scale on that axis. Histogram is very similar. Stem plots, if you're asked to do a stem plot. Stem plots, you usually do a key of some kind. It is not it would not be unreasonable to ask you to create any single one of these graphs. However, most of the time the graphs will be given to you and you need to be able to interpret them, not create them. Okay? Not to say that you'll never have to create one on the AP exam. It's possible that you will. I don't know. All right. If I have a quantitative variable, I'm going to ask you to describe the graph. When you describe that graph, you need to describe the shape, the center, the spread, if it has any unusual features, and you need to do so in context. Okay? So, shape. In general, Come on. We want to use the word approximately if we're using saying something is normal. We say it's approximately normal or symmetric. Okay. Some other words we might use. Skewed right or left. Another word you might use is bimodal or uniform. All of these are different shapes. What does skewed right mean? The tail is on the right. Skewed left means the tail is on the left. So when you're describing skewness, you're describing the tail, not the mode, not like that most frequent pile. You're describing where are the strange values. Okay? All right. You can have a mean, or if I give you a graph, you can either give me the mean or the median. They can be approximations. If they are approximations, you need to say approximately, okay? To estimate the mean, you'd be looking for a balancing point. Versus the median, you're looking for the 50-50 point. Where you have half the area to the left and half the area to the right. So, one of the things that when we went over Unit 1, one of the things that happened is I'd ask you to describe a distribution, and you would say it's skewed right so that that means the mean is bigger than the median. It is true that in a skewed right distribution, the mean is bigger than the median, but if you're describing the distribution, you're saying where that mean is. You're not saying just that it's bigger. You're saying you should give a numerical approximation for that mean. All right, spread. You can use the range. You can use the IQR. You can use the standard deviation. All of those are different measures of spread. Though certainly some are easier to approximate from a graph than others. Okay. If something has an outlier, don't call it an outlier unless you actually check that it is an outlier. Okay? Call it a potential outlier unless you want to do the rules to check. Okay? If it is very, very clear cut an outlier, that's a little bit different. But if it looks close, just call it a potential outlier. Some other weirdness you might address are gaps, where you might have like a graph that looks like this. Okay, let's say I gave you this dot plot and asked you to describe what you see. You would say bimodal. The mean is approximately 7.5. Would be right about there, yeah? Okay. If you say bimodal, then you should say with modes around 5 and 10. You could also say symmetric with a gap at 7, right? Do you guys see what I'm saying when I talk about those kinds of things? Being as specific as possible. This is not the time to try to write as little as possible. Okay? All right. And lastly, always, 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 context. The amount of times in questions that students get a P instead of an E because they didn't put units or didn't label things. Like, one of the things you want to do every single time is go back at the end of your test and say, if you have time at the end to check your answers, what I would be checking for is, did I include enough context? In other words, if I didn't read the question, could I still get a general idea of what this question was about? Your answer should be able to communicate to me what the question was about. So far, are we doing okay? All right. Other summaries. The 5-number summary. It includes the min, Q1, the median, Q3, and the max. We have a graph of the 5-number summary. It is a box plot. All right, now. This is also always done on an axis with scale, right? Okay. And so it's worth noting, like, in between your minimum and your Q1, you have 25% of your observations. In between Q1 and your median, you have 25%, 25%, 25%. Okay? So, is it possible that this section of your box plot is more stretched out than, say, this one? Yeah. And if that were the case, if the right side is more stretched out, that would most likely look to be skewed right. Because the right side, that right tail would stretch out. Is everybody okay? You can kinda tell skewness and stuff from a box plot. What you can't tell is how many modes there are. Okay? So this could have a mode here and here. This could also be normal, and you wouldn't be able to tell that from a box plot. Everybody good? Okay. So we might summarize a data set with the 5-number summary, or if it's a symmetric distribution, we might use the mean and the standard deviation. Okay? The mean is the total divided by the sample size. Does anybody remember what the standard deviation, not the formula is, that's ridiculous, you'll never have to use it by hand. But does anybody remember kind of like what is standard deviation?
Square root.
I'm not worried about how to calculate it. Just like in general, what does it mean?
The average distance from the mean.
Average distance an observation is from the mean. Okay. All right, we have 2 different ways you could decide is an observation an outlier. The first one was the IQR rule. Okay, so first of all, do you guys remember what the IQR is?
Interquartile range.
It stands for interquartile range, and how do I calculate it? Q3 minus Q1 is the IQR. The outlier rule. Okay, all right, so are you guys with me that this distance right here is my IQR? And so I could take this distance, give or take, and that's 1.5 times the IQR. Are we comfortable with that? Okay. So I want the reason I'm pointing this out is I want to give you guys kind of a visual cue for this outlier rule, okay? That's bothersome. There we go. I just want this one thing. There we go. All right. So, an outlier is too low if it's more than 1.5 IQRs below Q1. So according to my picture right now, is my min a quartile and an outlier? No. But what if my min was right here? Would it be an outlier? Everybody good? Okay. So the IQR outlier rule is you can do Q1 minus 1.5 IQRs or Q3 plus 1.5 IQRs. If I'm drawing a box plot and I, in fact, have a point that's bigger than that is an outlier, we would graph it as a freestanding point, and then this point right here is the highest non-outlier. It is also possible that my Q1 and my min are the same, so you don't actually see that whisker point. That's very, very possible. Okay? So there are box plots that look like this. Where the min and Q1 are the same. Okay? Everybody good? All right. Does anybody remember the other outlier rule?
Yes, it's the standard deviation.
What about the standard deviation?
Standard deviations from the mean.
More than 2 standard deviations from the mean. Okay? If something's skewed right, if you know the shape is skewed right, then it's very reasonable that the mean is greater than the median. Likewise, if a distribution is skewed left, the mean would be less than the median. The mean is going to go wherever the tail is. Okay. Other things we did in Unit 1. Almost done. Percentiles. Does anybody remember what a percentile is?
Set of population that's
Of observations that are less than a given observation. So, you guys, remember how I said that in between your minimum and Q1, you have 25% of your observations. That means Q1 is equal to P25, the 25th percentile. Are we good? All right, z-scores. They are the number of standard deviations above or below the mean.
Are they testing?
No, they're
Can I ask them a question?
sure. Are we good? All right. So you guys, what would it mean for what would the z-score for an outlier, give me a possible z-score for an outlier? 2.1 or negative 2.8, right? So like, are we good? So we go back up here, take this whole thing and say z greater than 2, z less than -2. Okay? And you guys, when we do the z-scores, when we do, say, a one-prop z-test, or we're taking that z, like doing a z-test, all we're doing is finding the z-score of our sample. And typically, like think about like that z-score for a 95% confidence interval was 1.96, right? Really close to this too. It's the exact same reasoning, okay? All right. Lastly, the normal distribution. We describe normal distributions. If you describe something as normal with a mean and a standard deviation, the minute you say normal, you're saying bell-shaped. Okay, so normal does describe shape. Then you usually approximate them with the mean and the standard deviation. We have something called the standard normal. It is the normal curve when what you are talking about are standardized z-scores. Okay? All right. Now, the empirical rule said if I go one standard deviation on each side, I have 68% of my observations. Again, only applies to normal distributions. If I go 2 standard deviations from my mean, 95%. Same 95% in between plus or minus 1.96. 2 standard deviations. 3 standard deviations, 99.7%. You guys, are you comfortable with me saying in between my min and my max is roughly like 99.7 is just about all, yes? Okay, so the distance from my min to my max is essentially 6 standard deviations. 1, 2, 3, 4, 5, 6. Okay? So if I gave you a normal curve or a normal histogram and I asked you to approximate the standard deviation, what you could do is the range divided by 6. Is everybody good? Okay. Lastly, the normal distribution in your calculator. For normal CDF, you would have the boundary. And you would find the area. Okay, so normal CDF is the one that asks you for a lower and an upper. You're describing the boundaries of what you were shading, okay? Whereas if for inverse norm, I could draw that exact same picture, and now what you know is the area, that'll be given to you, and you are finding the boundary. And that's where I'm going to stop today. Tomorrow, we do Unit 2. And then the second half, you'll work on that group quiz.